We'll be starting with the topic indices and exponential equation. Indices and exponential equation. Indices is talking about writing of variables like x raised to the power of a. This s is usually referred to as the base, while the a is the power. So we'll be dealing in this our first lecture with the laws that governs indices and exponential equation. So thank you. If you have not subscribed to my channel, please click on the red button below and subscribe. Thank you. The first law we'll be treating states that if we have x raised to the power of a multiplied by x raised to the power of b, the answer is equal to x raised to the power of a plus b. Why is this law valid? Let's check from our primary 2 mathematics. When we have 3 raised to the power of 2 times 3 raised to the power of 5, this 3 raised to the power of 2 can be written as 3 times 3. Then times 3 raised to the power of 5 is 3 times 3 times 3 times 3 times 3. When we multiply it all together, we have 3 raised to the power of 1, raised to the power of 2, raised to the power of 3, 4, 5, 6, 7, which equals to 3 raised to the power of 7. But if we don't want to follow this long primary convention ways, we can use this our first law of indices to solve it by writing it as 3 raised to the power of 2 plus 5. Then we have 2 plus 5 equals to 7. So 3 raised to the power of 2 plus 3 raised to the power and times 3 raised to the power of 5 equals to 3 raised to the power of 7. So thank you. We take the second law. Just like the first law, the second law, we have it to be x raised to the power of a divided by x raised to the power of b equals to x raised to the power of a minus b. The same process. If we have 3 raised to the power of 5 divided by 3 raised to the power of 2. Let's go back to our conventional way, how we used to solve it in our primary school days. How do we solve it? When we write this as 3 raised to the power of 5, we write it as 3 times 3 times 3 times 3 times 3 divided by 3 raised to the power of 2. We have 3 times 3. 3, 3, then we have 3 raised to the power of 1, 3 raised to the power of 2, 3 raised to the power of 3. So this 3 raised to the power of 5 divided by 3 raised to the power of 2 will give us 3 raised to the power of 3. And we can see using this our law of indices, we have it to be equals to 3 raised to the power of 5 minus 2, which equals to this our 3 raised to the power of 3. So let's move to the third law. The third law, we have a raised to the power of 0, we have it to be equals to 1. Anything raised to the power of 0 equals to 1. Somebody will tell me like 1,000 raised to the power of 0 is still 1. 1 million raised to the power of 0, we still have it to be 1. X raised to the power of 0 is 1. A raised to the power of 0 is 1. So if I have 1,000 raised to the power of 0, the answer is 1. Don't forget this. We'll be making use of it in the course of our further studies. Law 5. Law 4. When we have a raised to the power of x, a raised to the power of y, the answer is equals to a raised to the power of x times y, which equals to a raised to the power of y, then x. The reason why we can write this is because multiplication is commutative. What do I mean by commutativity? Commutativity implies that if we have from a set and we have an operation operating on the set, if A asterisk B is equals to b asterisk a. We say the operation is commutative. So back to our business, when we have 3 raised to the power of 2x, this can be written as 3 raised to the power of x, and this can be written as 3 raised to the power of 2x. Depends on how you want to make use of it. In the course of these studies, when we are solving exponential equations, you will see how we make use of this law in the process. Then we move to law 5, where we have a all over b raised to the power of x. This will be distributed to a and b. So I have it to be equals to a raised to the power of x all over b raised to the power of x. A over b all raised to the power of x is equals to a raised to the power of x divided by b raised to the power of x. Then we can also move backward. It's not always the question that will be given. We will have a question like this and we will be moving forward. The law implies that a raised to the power of x divided by b raised to the power of x can also be written as a over b raised to the power of x. Let's pick an example. When we have 10 raised to the power of 5 divided by 5 raised to the power of 5. Can you tell me what the answer is? Yes, you are correct. 2 raised to the power of 5. How? We follow this law. We assume that our a is 10, our b is 5, then our x, which is the same power here, is 5 and 5. So we move backward to have 10 all over 5 raised to the power of 5. 10 over 5, we have it to be 2 raised to the power of 5, which equals to 32. We move to the next law, law 6. The 6th law is just like the 5th law, where we have AB raised to the power of x equals to a raised to the power of x multiplied by b raised to the power of x. When you have product of two variables and you have a power they have in common, the power will be distributed for both of them. So let's look at it. Example, when we have the same 2 raised to the power of 5 times 5 raised to the power of 5, then this we can have it to be equals to 2 times 5 raised to the power of 5, which equals to 10 raised to the power of 5. If you have any question you want to ask me from the following laws that we've treated, please write them at the comment section. I will respond as fast as possible, as early as possible to the question. Let's take law number 7. When we have a raised to the power of -1, it is 1 over a. A raised to the power of -1 can be written as 1 over a. Example, if I have 3 raised to the power of -1, I know it is 1 over 3. Let's go to the 8th law. 8th law is talking about having a radical power. When I have fractional power, which will lead to radical, when we have a raised to the power of a fraction x over y, then it will be equals to a raised to the power of x, then at the root of y. A raised to the power of x at the root of y. Example, when we have 8 raised to the power of 2 over 3. This is an example. 8 raised to the power of 2 over 3. How can we solve this? We write it as 8 raised to the power of 2. Then we take the cube root or the cubra of this. The square of 8 is 64. And we take the cube root of 64, which equals to 4. Other laws are just combination of these 8 laws which we have taken. Then we'll be taking the 9th law and the 10th law. 9th law and the 10th law. These laws we'll be making use of them in the exponential equation. Exponential equation, we'll be making use of the laws in the exponential equation. Please permit me to rub this off. So when we have a raised to the power of x is equals to a raised to the power of m. A raised to the power of x equals to a raised to the power of m. Then I will say that x is equal to n. Why? Since the bases are equal, the power must be equal. Since the bases are equal, the powers must be equal. That is the 9th law, and we'll take the 10th law. When we have a raised to the power of x equals to m raised to the power of x, I will say that a is equal to n. Guess why? You are correct. Since the powers are equal, the bases are also equal. So you write, since the powers are equal, the bases are equal. So this is the summary of the laws of indices. Every other law or any other law can be derived by combination of 2 or 3 of these laws to get the law. So if you still have any other law in your mind that you think I've not treated and is not a combination of any of these, please, you can also write them in the comment section. Thank you very much. I'll be looking forward to meeting you in the next video, where I'll be giving concrete examples on indices and exponential equation. So thank you very much. Stay blessed.